There we go. All right, so chapter 1, angles and trig functions. Now, as we get into this, we're going to see just right off the bat kind of a new way of looking at angles too. Angles you've always seen as degrees, correct? You had 0 to 180, 0 to 360, those types of things. We're going to have a new type of angles to look at. We're going to introduce Greek letters to you. All right. In trig, they use Greek letters for variables quite often. Why Greek? Well, I mean, math kind of originated from the Greeks, but those are just kind of the given ones. So right off the bat here, we got to do some review. We got to talk about some things with angles. We'll talk about the Greek letters, those types of things. Just straight review to get us back on page of where we need to be. So first thing, an angle. If this is your angle, okay, you would have an angle. You could identify it. There are three different ways to identify it. One, you could identify it by one point at the vertex. Two, you could identify it by 3 points, one at the vertex, one on each of the legs, or three by a little number or something that's indicated inside the angle. All right, for us, let's just call this guy C. This will be A, and this will be B. All right, so we could call this angle B, or we could call it angle CBA, or ABC, of course. Okay. Vertex. Which letter here would be my vertex? B. All right. This is my vertex. All right. And if I'm looking at this angle in a certain way, if I'm saying that my angle starts here and goes to here. All right. So if my angle starts on this right side leg, goes to my left side leg, the side it starts at, that's called my initial, or my initial side. The ending side, or where the thing stops at, is called your terminal side. Okay, so we have our initial side and we have our terminal side. Still good with that so far? Okay, I don't think any of this is real nuts right off the bat. We'll be looking at it in the case of the coordinate plane. Quite often, we're going to be referring back to that. This here is going to be our initial side for our angles. Okay, if we go in this direction, this would be a positive angle, or positive degrees. If we start there and go this way, it's going to be a negative degrees. So you start on the right side of the axis. If I go counterclockwise, that's the positive direction. If I go clockwise, it's the negative direction. Okay. And just a reminder too, this follows the same pattern as our quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You guys remember that from geometry as well? You don't remember the quadrants? Okay. All right. So what we'll talk about then, you might not have talked about the initial and terminal. All right. In geometry, typically you have two sides of an angle, or two legs, right? You get a vertex, a leg, and a leg. All right. For us, though, in geometry, you were more worried about that one angle on a shape, or just somewhere in space, correct? For us, it's going to be more attached to this coordinate plane here. All right, and that's why we have to look at this as the initial. So if this is the angle I'm talking about, this is initial, this is terminal. Okay, it starts here, finishes here. Okay, just a couple other things on angles. Go on, scroll. There we go. What's an acute angle? Less than 90 degrees, okay? So it's an angle, it's less than theta, less than 90. This is a Greek letter, you'll see that here in a minute. Okay, and it would typically look something like this. Okay, A right angle, what's a right angle? 90 degrees, correct. All right, so we'll say that theta is 90 degrees. And it's also a quarter rotation. So that would be going a quarter of the way around your circle on your coordinate plane. Okay, we go from here to here. And like you said, it's a right angle. Okay. Obtuse. What's an obtuse angle? Greater than 90, but less than. Correct. Yeah. So 90 degrees is less than theta is less than 180 degrees. All right. It would look something like this. The only reason I say about I stopped her and said, she said greater than 90, which is correct and probably what you've learned before. It stops at 180. All right, bigger than 180, we have something called a reflex angle. We'll get to that later. All right, and then lastly, we have what's technically a straight angle. A straight angle is equal to 180 degrees, and it would be a half rotation. And a straight angle is basically a straight line. Okay. So that's kind of our angle review to cover. Hopefully nothing's really too crazy so far. So Greek letters and notation, let's just cover that real quick. This here, as I said, this is called theta. And this is most commonly going to be what your angle is referred to. Okay, that's just kind of the Greek letter that they use for almost any angle. All right, some other ones that we're going to cover at times. You have this guy, it looks like a sideways fish. That's alpha. I just want you guys to know what these letters are and how you say them. Otherwise, when I start throwing out stuff, you guys are going to, huh? You know what I mean? So I'm just covering it now. That's alpha. A big B with a tail, that would be beta. And then this guy kind of looks, I said it looked like a seagull. That's going to be gamma. Okay? Good. All right. So theta is just a zero with a tail. Alpha is a sideways fish. Beta is a big B with a tail. Gamma is a seagull. All right. And those are basically the four big ones that we will cover and use throughout the year in trig. Wait, what's the last one called again? Gamma. GAMMA. All right. So as I said, everything you've done for angles is in degrees so far, correct? It's on a standard scale of 360 degrees is one revolution. Okay? Now, here's the next type that we're going to use a lot. It's called a radian. Okay, so by definition, one radian is the measure of the central angle of a circle that intercepts on an arc equal to the length to the radius of the circle. Radian is the measure central angle of a circle that intercepts on an arc equal in length to the radius of the circle. So in formula form, which can be beta, that's going to be the length of the intercepted, spell, length of the intercepted arc over the radius. Right? This is going to be the beta. We know what a radius is. It's essentially going to take this guy and cut it in half. So we have the 2 times the radius over the radius of 2. Wow, I cannot spell arc. That should be A-R-C, not A-C-R. All right, and then consider an arc length S on a circle of radius R. The length of the central angle of theta intercepts the arc is theta S over R radians. I have a little picture for this as well. R, boom. That would be a picture for that. Again, this is just a lot of definition type stuff. So if you're sitting there looking at this right now going, what the heck is he talking about? This is merely definition type stuff that we have to kind of knock out. Don't worry, you'll understand here. Yeah, theta equals S over R radians. Yes. This? Yeah. How many of you guys have ever messed up on your calculator and if you look up in the top corner it says DEG and all of a sudden it's an RAD and your numbers come out weird? Yeah? That RAD is radians. Okay? So that's one thing we will have to look at our calculators at some point here and be able to go back and forth between degrees and radians and know at which times to use each one. Okay? All right, we good to move on? All right. So the first thing we have to see is we know degrees. Okay? Degrees is a given. We want to know how that relates to radians. That's the easiest way to look at this. Just relate it to what we know already. All right, so if I have one rotation, so one full rotation, how many degrees is that? Correct. It's 360. All right, in terms of radians, one full rotation is going to be 2 pi. So one rotation is going to be 2 pi radians. In that case, a half a rotation is going to be what in degrees? 180. So based off of what you see, if one rotation is 360 is 2 pi, what do you think 180 is going to be? Pi. Okay. All right. So one rotation is going to be 2 pi. Half rotation is just pi. So if I want to convert from degrees to radians, I'm going to take this. We know, we just talked about it above, pi radians is equal to 180 degrees, correct? We just said that, so let's use that for our conversion rate. So one, if we want to go from degrees to radians, what you have to do, we have to multiply your degrees by pi radians over 180. If I want to go from radians to degrees, I multiply my radians by 180 over pi radians. As we go along too, we're going to do a little chart down here momentarily. We're going to show off kind of the most common ones that you're going to see. So you'll be able to start memorizing that it's, a week from now, you're going to be, I must say 45 degrees, and you're going to say, okay, pi over 4, right? So, good if I scroll a little bit. Okay. So, example. I have 30 degrees. I want to go from 30 degrees to radians. All right. If I want to go from 30 degrees to radians, well, I just wrote it down. If I want to go from degrees to radians, I multiply my degrees by pi over 180, correct? So I'm going to have 30 degrees times pi radians over 180 degrees. Now remember, whenever we did our conversions, we always did like our high to low, we canceled out the units. You remember doing that? All right, especially if you had me. So I can cancel out my degrees here. And now I'm left with 30 pi over 180. This radians word, this pi rad, you really don't have to have the rad in there. Okay? I hope you guys know if you see a degree mark, it's in degrees. If you see a pi, it's in radians. Easy enough? Okay, so I'm just going to drop the radian word. All right, so now I have 30 over 180. Simplify that fraction. What, zeros are gone. 3 over 18 is going to be 1/6, right? So then that's just going to be equal to pi over 6. And that would be in radians. So 30 degrees, pi over 6. Try that guy. 135 degrees. All right, everybody get an answer? No comment? Okay, who did get an answer? What'd you get? Anybody else? Okay, let's check it out. I get 135 multiply that by pi over 180, right? So it's 135 pi over 180. And then if I simplify that, that is actually going to come out to 3/4. So I'm guessing we messed up a little bit in our simplifying. All right, but yeah, that would be 3 pi over 4. All right. Yeah, divide by what? By 5. And then divide by, I think I did by 5 and then by 9, maybe? All right, but yeah, that would simplify. All right, let's do one the other way. If I want to go from pi over 3, and I want to go to degrees, go ahead and try that. So if you look up at number 2, radians degrees, you just multiply by 180 over pi. Just flip it. You flip your conversion. All right, anybody want to share what they got? 60? Did you say 60 pi the first time? Okay, your pi should have canceled out. Okay, so we're going to have pi over 3 times 180 over pi, correct? Pi's and pi's cancel. Give me 180 over 3, which is going to be 60, and that would be degrees. 60 degrees from radians to, from radians to degrees. And again, you really don't have to put the rad or the radians after them. I'm okay if you don't, but just know the difference. If there's a pi, it's radian. Degrees, it's degree. Degree mark, it's degrees. Still good? All right, so let's make a little chart here with our common ones. I think hopefully you guys have enough room. So let's go. We'll talk about rotations, and then I'll give you the radian measure and the degree measure. Ooh, I'm not sure I'm gonna have enough room. Might have to make a second column. It's all right. All right. If I have 1/12 of a rotation, it's pi over 6. It's gonna be 30 degrees. I'll write out these degrees first. 30, 45, 60, 90, 120, 180. We'll stop there for right now. Okay. So those are my most common degrees. Okay, 45 degrees is pi over 4, which should be 1/8 of a rotation. Pi or 60 degrees would be pi over 3. That'd be 1/6 of a rotation. 90 degrees is pi over 2, which is a quarter rotation. 120 degrees would be 2/3 pi. That's a third of a rotation. 180 degrees, we already talked about that. That would be pi radians, which is half a rotation. Alright, then a couple more to hit. 240, 270, 315, 360. Again, these are just your most common angles that you're going to see. 240 degrees would be 4/3 pi, which is 2/3 of a rotation. 270 degrees, 3 pi over 2, which is 3/4 of a rotation. 315 degrees, 7 pi over 4, which is 7/8 of a rotation. And 360 degrees would be 2 pi, which is 1 rotation. And you'll see as we go forward, there's some patterns here. Okay, and your patterns are going to be based off of kind of what multiple of the degrees are. So for instance, everything that's a multiple of 60, 120, 180, and then 240, the bottom is going to be 3, 3, odd case because it's a half of 3. Everything that's a multiple of 45 over 4, counts it's 90, over 4, and so on. Okay, so you'll see that they pair up. Usually 45 degrees is over 4, 60 degrees is over 3, 30 degrees are over 6, and so on. All right, so these are your most common ones within one rotation. All you're really doing tonight, and for this first assignment, going back and forth between radians and degrees. That's really it. Okay, just get a little idea what that is, what that feels like. Just see that they're exactly the same. And why we use radians, as we get farther along, things will get really, really ugly if you try to do everything in degrees. Especially when we get to a point where we are graphing sine and cosine functions. Those are waves. Okay, they look like sound waves. You guys ever do sound waves in physics or anything like that? No physics?
Well, we do like frequency waves.
Yeah. Yeah. That's what it's going to. Did you get into it much or not?
Not very much, but we know what the terms are.
Okay. Yeah, so frequency, amplitude, that type of phase shift, those types of things. Okay. Those are sine and cosine waves. So when we get to that, that's how we're going to look at those in terms of radians, because it just makes life a whole heck of a lot easier, and so on. All right, guys. That's the first trig lesson. You guys like the note sheets? Yes? You guys all can find a 3-ring binder or something like that?
Yeah.
Okay. All right, that's it for today. I'll put an assignment up. If any of you guys have any